Hi everyone! The big theme of this week's case study was certainty. The big idea here is that communicating levels of certainty in science can be really difficult for a number of reasons. One of those reasons is that, as we've talked about before, the work of science is very complex and doesn't distill down very well. Another reason that, also as we've said before, meaning is created by both the writer and the reader, and writers and readers may assign slightly different meanings to the same words. A really good example of this is the Holland reading, so let's just get on with this week's case study questions. First, what does Holland say about words indicating certainty? The big point of the studies Holland shares is that different people assign different levels of certainty to the same words about certainty. Just look at this graph. In this study, the researchers had participants assign different percentages of certainty, or what they thought the word meant, to different words, and the meanings are all over the map. Just take a look at probable. Different participants assigned anywhere from 20% certainty to 80% certainty to the word probable. That's a huge difference. Holland's suggestion is to use numbers to indicate certainty where you can to sort of ameliorate this a little bit, but the difficult thing is that's not always possible. So what are the real meanings of those words? Well, that's a trick question. Remember what we said before, words don't have intrinsic meaning. They're not a window onto reality. Words only have the meanings that people assign to them. So if different people assign different meanings, then those words have different meanings. It just makes communicating precisely a little bit more difficult. All right, let's turn to the questions about the climate change scientists. I want to back up and give a bit of background though. The climate change reading comes from a book by Professor Linda Walsh called Scientists as Prophets, which is all about scientific uncertainty. Actually, it's about scientific uncertainty and political uncertainty, or specifically, uncertainty when it comes to policy making. To frame this discussion about how scientific uncertainty and political uncertainty are related, I'm going to talk a little bit about a concept called stasis. The idea of stasis comes from ancient Greece, and it's basically the principle that a group of people deciding things has to go through a step-like process in their decision-making. First, they must decide to agree that events occurred. This is called the stasis of fact, say if someone was killed. Then they have to decide on the definitions of those events. Was it murder or was it an accident? What caused the event to happen? This is called the stasis of definition. Then you decide on the quality of that event. This is called the stasis of quality. So is this thing that happened a good thing or a bad thing? This is sometimes called the stasis of value because it's where we assign value to things. And finally, the last level of stasis is the stasis of policy or action. What do we do about the thing that happened? Often, scientists and policymakers like to think that scientists stay at stasis levels 1 and 2, fact and definition / cause and effect, while policymakers, congresspeople and such, then take up the issue, decide whether it's good, bad, or whatever, that stasis of quality or value, and then decide what to do about it. The policymakers make policy and take action. Walsh calls this the is-ought divide, with scientists on the is side and policymakers on the ought side. However, things don't actually work like that, because even when scientists make claims at the stases of fact or definition, levels 1 or 2, people often hear those claims in terms of value and policy. Take, for example, the congressional hearings about tobacco in, I think it was the 1990s. So scientists said that nicotine causes people to become addicted to cigarettes. That's stasis level 2. Nicotine causes this, or addiction to cigarettes is caused by nicotine, which is in cigarettes. But we all hear that statement in terms of our values before the policymakers ever even get a hold of it. We think addiction is bad, so we must do something about this. Probably something the tobacco companies won't like. It's important to say here that Walsh doesn't say this phenomenon, this hearing of stasis levels 1 and 2, in terms of stasis levels 3 and 4 as a bad thing. It's just what people do. It's just how language works. Okay, so let's think about this in terms of the climate science debate. Now, Walsh is talking about a very specific international group of climate scientists writing a series of specific reports, and she does a really in-depth analysis, but the basics of what happened is this. A group of scientists were tasked with reviewing previous findings on climate change. They were to put this review in a report so that policymakers could decide what to do about climate change. Again, we see this is-ought divide at work. Scientists on the is side, policymakers on the ought side. And so when the scientists reviewed the literature, it was bad. Not that the literature was bad, it's that the climate is changing and that's going to be bad. Furthermore, the climate scientists agree pretty strongly that humans caused the climate to change. They agreed it wasn't a natural process, but a human-made one. Okay, so humans caused the climate to change, and the impacts of climate change are going to be pretty bad. They basically agree on those two things. But the specifics of those two things are more up for debate among the scientists. When exactly will these specific impacts of climate change happen? How much will the sea levels rise by such and such a year? Well, no one can say that for certain. That's the future, not even the scientists. There is still quite naturally some uncertainty, again, because it's the future. But these scientists know enough about the way things work to know that if they put a document out there with some uncertainty in it, policymakers who disagree with climate change will use that uncertainty as a way to say, we don't have to do anything about it. And the scientists know how bad things will be if nothing is done, so they use a few specific strategies in their report. And this is where the question from today's case study comes in. What strategies did the climate change scientists use when writing the climate change report? There are two basic strategies they used. First, they adjusted their language to dilute some of the uncertainty, to make the claims more certain than they actually were in the original studies. And they also used visual rhetorical strategies as well. For example, using the color red to predict possible warming scenarios, to make the possible scenarios seem like it's for sure going to happen rather than something that is still in fact a prediction. All right, last question. What does Linda Walsh say about the effectiveness of these strategies? Well, essentially the strategies were persuasive to the policymakers who were already concerned about climate change and who wanted to do something about it, but they didn't work for the people who already didn't believe the climate was changing, or who professed not to believe the climate was changing, or that people were the cause of climate change. Policymakers who didn't want to do anything about climate change accused the group of junk science, bias, and corruption. And so, at least in the United States, you have the political situation we have today. No real major policy changes in terms of preventing or ameliorating climate change. Again, at least in the US. We could talk about the policy changes almost every other country in the world has made, but that's not the topic of today's case study. All right, if you'd like to revise the case study, let me know. Otherwise, see you later.